Hello and welcome back for another VMK in the C++ introductory series. In this VMK I'm going to show you how to make a computer program make some decisions. Usually whenever you create a program you want to give it some smarts so that depending on what kind of input you give it, it responds accordingly. You don't want to have a program that just does the same thing over and over. That's not really very much fun. So in this video, I'm going to show you how computer logic works. We're going to jump right into Visual Studio and start writing a little program that we can play around with the logic so we can actually see how it's performing. We'll just go under New Project. I'm going to create a new Win32 console project and I'm going to call it Computer Logic. And under Application Settings, I'm just going to have Console Application and then everything else is going to be unselected. This will give us a clean project to work with. In pretty much any program that you write, you will need to have some sort of branching structure. And the way that branching works in C++ is you use the if statement. So let me demonstrate how this works. We can display text to the screen by typing printf, and in quotation marks here we can type what we want to display on the screen. So I'm just going to write hello and then add a carriage return. If I press Control F5 on the keyboard, it will build the program and run it for me. And you can see here at the top left-hand corner it says hello because that's what my program said is going to do. I'm going to add an extra printf statement now, but it's going to only print depending on a variable. So first thing we're going to need is a variable. The variable I'm going to be using is a boolean, which means this variable can only be true or false. There's only two values that this variable can contain. So I'm going to call it bCondition. I'm going to set this variable so that initially it's set to true. Now I'm going to write my if statement. If bCondition, then we're going to print f. And here I'm going to say variable is true. So what this will do is, if my condition is true, this part here will print. If my condition is false, it won't print on the screen. Let's press Control F5, build the program again, and now we can see variable is true and then it prints hello. Now if I change my variable from true to false and rerun my program, you notice that the first line of text, the one that says variable is true, does not print on the screen. It only prints hello, because this if condition actually evaluated to be false, which means it skips over the statement in here inside of the braces. I can add in an extra condition here, else, which means print this part down below if the first condition is false. Since my condition here is false right now, then it will print whatever I type in here. So I'll type variable is false. So now notice that variable is false is printed to the screen, and then it says hello. If I change my variable to true and rerun the program, it says variable is true now, and then it prints hello. So this is the if-else structure that you can use to print things onto the screen depending on the condition of a variable. Now let's just change this up a little bit more. Instead of using a Boolean variable to do my condition checking here, let's change this to be an integer. I'll create an integer I value, and I'll set my integer equal to 0 initially. In my if statement here, I'm going to write if I value is equal to 0, then we're going to print variable equals 0. I'm going to get rid of this for now. And also I'm going to get rid of that. Alright, so on the screen we see variable equals 0. That's correct, because this up here, it evaluates my I value variable to be 0, and 0 does equal 0, so therefore this condition here ends up evaluating to be true. Because it's true, it goes into the if statement, which means it prints this printf statement. Now what happens if I change this value to be 10? If I rerun my program, you notice nothing displays on the screen anymore, because now this part here is false. So we can go in again and this time write in an else statement saying printf variable not equal to 0. Like so. But now we can do something else as well. Let's say we wanted to display one statement if the value is positive, another statement if the value is negative, and then a third statement if the value is equal to 0. Well, with what I've shown you so far, you only have an if and an else, so you only have two conditions. But you can actually use this if-else structure to make as many conditions as you like, sort of in series. And the way you do that is as follows. Let's say we want to check first to see if the value is positive. So we're going to check to see if I value is greater than 0. If that's the case, then we're going to print to the screen positive. Else, we can add in an extra if statement here, I value less than 0. Then we know that our value is negative. Otherwise, we can write in else like so. So here's the logic. If this is true, so if I value is greater than 0, it's positive. If this one fails, it goes to the next else statement and then checks to see if I value is less than 0. If this one fails, it goes to the next one. And then it just prints 0 if that's the condition. So let's try this out. Our value right now is set to 10, which means it's positive. So positive displays on the screen. If I change this to minus 50, for instance, we have negative printed to the screen right here. And if we change our value to 0, then it prints a 0 on the screen. So that's the way we can use the if statement and some simple logic to branch our program so that it displays different things on the screen. Another condition statement which is very helpful is the not statement. We usually use this whenever working with Boolean variables. So let's go back to a Boolean variable here. And I'm going to set this guy up to be true initially. Now we're going to check for the condition, and if it's true, we're going to just display true on the screen. Otherwise, we're going to display false. So this behavior should be the same as what we had before. If it's true, it displays true. If it's false, it displays false on the screen. Now, what we want to do is actually negate this condition so that we get the opposite happening. If it's false, we want to display true, and if it's true, we want to display false. The way we can do that is by adding in the not operator, which is the exclamation point found above the number 1 button on the keyboard. So if we put that in front of our condition will negate itself. So in other words, right now, this is false. If we negate it, it turns to true. And if the if statement is true, it will print this out. So let's try this out. You notice it's displaying true now, even though our variable is set to false. And if we set our variable to true, then on the screen we have false. So the negating operator here is working fine. Now when creating control logic inside of your program, you'll usually want to use compound conditions. What this means is you'll have more than one variable that you're checking at the same time inside of an if statement. And if all of them are true, or if some of them are true, or if a certain combination of them are true, then you want to execute your if statement appropriately. Otherwise, you want to handle it some other way. The way you handle these compound statements in C++ is you usually use something called AND or something called OR. With these two statements, you can compound your condition checking in such a way that you can achieve whatever you desire. Let me go into PaintShop Pro here and show you how this works. If you have two values, let's call them value A and value B, and we'll initially just say that these are Boolean values, so they could be either true or false. If you set value A to be true and value B to be true as well, and you use the AND operator between these, so in other words you say value A and value B, the result of that is going to be shown here. So if both of these are true and you use the AND, you're going to get true as the result. If either of these are false, or both of them are false, and you use the AND operator, then the result will be false as well. And this makes sense if you think about it, because the AND operator says something will be true if both items are true. Otherwise, they're going to default to false. So that's what you see here in this truth table. The way you use the AND operator in C++ is you use the ampersand symbol stacked two beside each other like so. So let's go try that out now. So I have here, let's do B value A, and another variable here, B value B. I'm going to set this guy up to be true, and I'll set the other guy up to also be true. And then inside of my if statement here, we're going to check. If A value and B value, then we want to display this down here, which is true. Otherwise, we're going to display false. So when we run this now, we should see true on the screen, because both A and B are true. So we get true. That's correct. However, if we change either of these to be false, you'll notice that false displays on the screen. And as a matter of fact, if we make both of them false, you'll notice false remains on the screen. So that's where we get this condition here. If either of these are false, we get false on the screen. If both of them are true, we'll see true. The other operator that is commonly used is the OR. And the truth table for the OR is shown down below. The way this works is if either of value A or value B are true, then the result will be true. If both of them are false, then the result will be false. So if both of them are true, we'll get true. If either of them are true, we get true. And the only way we can get false is if both of them are false. Okay, let's try this out then. To use the OR operator, instead of using the ampersand sign stacked beside each other, we use the pipe sign. And you can find the pipe sign on the keyboard located usually below the Enter key, or sometimes it's also found below the backspace key or somewhere close to it. So let's try this out now. We have both of these values here set to false, so our result is outputting false. If we make one of these true and run it, you'll notice that the output is true. So there we go. We have this OR condition working in C++ now. The last commonly used operator, which I've already shown you, is the NOT. And that just basically negates the current value of our variable. So if our variable is true, it causes it to go to false, and if it's false, it causes it to go to true. And the NOT operator is represented by the exclamation point, which again you can find above the number 1 key on your keyboard. The last thing that I wanted to demonstrate here in the logic section is bitwise operations. What we've been doing is variable operation comparisons. So we're checking to see if a value of a variable, like an integer, is greater than. You can also use comparisons with greater than or equal. Those would be done with the following. Let me just show you that. Let's say we have a floating point number, and we set this floating point number equal to 3.5, for instance. If we want to check to see if this value is greater than or equal to 4, then you would do the following. So you have greater than or equal, you have greater than, you have less than, you have less than or equal to, you have not equal to, you would do that. And if you want to compare if they are equal, then you use double equal sign like so. So those are all the common operations you use with your logics inside your if statements. However, there is one other which I want to discuss, and that's the bitwise operations. Let me show you how they work. Let's say we have an integer, And I'm going to set this first integer up equal to the number 12. Actually, I'll rename this to be IA. Then I'm going to create another integer. I'll call it IB. And I'll set this guy up to be equal to 5. Now, inside of my if statement here, what I'm going to do is a bitwise operation. Actually, I'm not even going to use an if statement. I'm just going to show you the result here. I'm going to use another variable, IR, and this one's going to contain the result of my bitwise operation. So, initially, we're going to start off with bitwise AND. Notice that the bitwise AND only used 1 ampersand. And what I'm doing is I'm taking this value, 12, and ANDing it with 5. What do you expect to get here? Well, let's display the result to the screen. When we run it, we can see that the following gets printed, 4. So 12 and 5 is somehow 4. Interesting. Well, let's try the OR. OR, again, is similar to regular OR, which is 2 pipes, but with bitwise OR, you just use 1 pipe. So let's compile this and see the result. We get 13. The way that this is working is on a bit-by-bit basis. So you'll need to go back to the previous VMK where I showed you how numbers are broken down into binary format. The number 12 is actually 1100. The number 5 is 0101. Now the result is a bitwise operation between the two up above. So if we have this one here, an OR, what's going to happen is the result that gets calculated here is a bitwise OR operation that happens bit by bit. So we're going to take this bit here and OR it with this one. So the result of 0 and 1 would be 1. Then we have the next column, 0 and 0. When we OR those together, we get 0. If we take 1 and 1 and OR those together, we get 1. And finally, if you have 1 and 0 and OR those together, you get 1. So the result here is 1101. And if you convert this to decimal, then you get 13. So again, if we run this through, you see we get 13 here. If we change this to an AND symbol, then you're actually doing a bitwise AND. So you're going through bit by bit and you're ANDing the bits together. So 0 and 1 is 0. 0 and 0 is 0. 1 and 1 is 1. And 1 and 0 is 0. So the result is 4. 0100 is 4 in decimal. And there you go. There's the result. So make sure you're using the right operation for whatever you're trying to achieve. Usually you use bitwise operations whenever you're working with hardware. However, sometimes it is helpful to decode certain kinds of actions in a bitwise string. Then using this bitwise string, you can AND it, OR it, or make complex operations to give some sort of result, which you then interpret based on the bitwise pattern. But that's a little bit more advanced for this tutorial. What I just wanted to show you here is there is a difference between regular AND operations, where you have 2 AND signs, and bitwise AND operation, where you have just 1. Same thing goes with OR. Regular OR is 2 pipe symbols. Bitwise OR is just 1 pipe symbol. Okay? So if you have any questions about this specific tutorial, feel free to go to the website and under the community section, once I finish encoding this video and converting it all over, you'll notice that there'll be a C++ VMK number 2 here where you can ask questions specific to this VMK. If you're finding my videos helpful and you can support my website, you can do so by clicking on any of the PayPal icons found throughout my website or clicking on the Google ads found on the side. You can also help me out by purchasing a membership or any items that are found in the store.